how to solve an inequality like this one. All you have to do is to draw the parabola fx equal, just draw this function. If you want to solve this inequality, find the roots. I mean the x, such that x is a root if f of x is 0. But remember, we already found the roots of this quadratic, and we got x equal to minus 1/2 and x equal to minus 1/6. If you don't remember those roots, remember that you can find these roots using the quadratic formula, and those are the roots. And since this is a parabola, we can draw a sketch of it, not exactly. We know that it opens up because this coefficient is positive, like this. And we also know the roots. Here are the roots. The x, for which the y is 0, we shall call the x-intercept, while y is 0, which means the roots, but we have those roots over here. Those are located here, Draw a rough picture, not exactly, but locate those points, more or less. And then, let's now solve the problem. And at this stage, at this moment, we can solve the problem, because if you want to find for which x this inequality is greater than 0, which is the y, just all the points over here, y's, are such that y is greater than 0, all those. Then, but you have to find is the x. You want to find the x, this is the x, and this is the y. This is the x, and this is the y. And then, see, if you move this way, those x, for this x, y is greater than 0. Even here, for those x, y is greater than 0. All these x to the left of minus 1/2 are such that 3x squared plus 2x plus 1/4 is greater than 0. And the same happens the other side. For all this x, the y is greater than 0. As you can see, moving this like that, For all those x, y is greater than 0. Then the solution to the inequality with the greater sign in this way, 3x squared plus 3x squared plus 2x plus 1/4 greater than 0, are the x to the left of minus 1/2. What we have here in an interval, and then union the x to the right of minus 1/6 up to infinite. This is the answer, but see, there is a difference here between our question and the answer, because here says greater than or equal to. It means that for some x, this may be equal to 0. Just here and here. Then this is called a strict inequality. This is a non-strict inequality. If the inequality is non-strict, it means that it allows the zeros of the form then you have to include the ends of the interval, the right end of this interval, which is minus 1/2. But it's close, you know. Close means that you include this in the solution of that, because it is greater than or equal to. The same happens to the right. You know, you have to include minus 1/6. This union is the answer to the problem for greater than or equal to. But if you want only the solution for greater than, you have to change this closed interval with an open interval, you know, with a parenthesis, minus infinite up to minus 1/2, without including 1/2 union, minus 1/6 to infinite, without including minus 1/2 nor minus 1/6. Neither one of those, you know, is open. This is an open interval, and this is the close when you have equal here. This is called semi-close. You can say close because here includes the ends, but it's close to the right, but it's open to the left, you know, because minus infinite is not a number. This is the way to solve inequalities using the graph of the parabola. The graph of the parabola. Say for this inequality less than or equal to, the solution are the x from minus 1/2 to minus 1/6, because for them the y is less than 0, and if you include the ends, you have the solution to this inequality that is not a strict inequality, but admits the 0 of the expression. It depends on what kind of problem it is, but anyway, RDS between minus 1/2 and minus 1/6, like this. Remember to use the graph of the parabola to solve inequalities in the real world, you know, using real numbers, and the x and y axis. This is always possible to be done for trinomials, for quadratic trinomials.